My name is Lee Adrian Fajarillo and these are the materials to be used for the experimentation. We need the 5 paper planes that were instructed for us to make and 3 large paper clips. 3 large paper clips are gonna be attached to either the front, the middle, or the back portion of the paper plane, and we will test it out. Simple paper plane. The Phoenix paper plane. The tube paper plane. The super canard paper plane. The Sky King paper plane. Let's now move on to the flight testing of these paper planes, and the first one we're gonna test is the simple paper plane. For the simple paper plane, the Phoenix, the Super Canard, and the Sky King, we're gonna throw it like how we usually throw our paper planes. The simple paper plane when thrown is very unstable due to its design and because it lacks stabilizing surfaces with regards to its design, and once thrown, it travels a short distance then crashes. Moving on to the tail-heavy simple paper plane. So this is what the tail-heavy simple paper plane is gonna look like. The tail-heavy simple paper plane once thrown crashes immediately because of its instability and because it's already tail-heavy and the aircraft could not fly. Middle-heavy simple paper plane. The middle-heavy simple paper plane once thrown pitches up then crashes immediately because of the weight applied to it. Nose-heavy simple paper plane. The nose-heavy simple paper plane flies shortly then develops into a spin immediately because of the weight applied to its nose. Moving on to the flight testing of the Phoenix. The Phoenix when thrown is very stable in all axes due to its design with stabilizing components, and its flight dynamics is very good. Tail-heavy Phoenix. The tail-heavy Phoenix once thrown immediately crashes because the weight and drag caused by the paper clips is already great. Moving on to the middle-heavy Phoenix and how it looks like. The middle-heavy Phoenix once thrown flies for some distance then pitches up immediately and then loops, then stalls immediately and crashes. Moving on to the nose-heavy Phoenix and how it would be looking like. The nose-heavy Phoenix flies for some distance then pitches down because of the weight applied to the nose. Due to its design, it fights off the weight applied to the nose and it tries to fly, but due to the amount of weight applied to the nose, it starts to pitch down then crashes. Next up is the flight testing of the Super Canard. The Super Canard, once thrown, pitches up slightly, stalls, then recovers from the stall and then flies. This is due to the fact that it has two wings. In the first wing, you can see the smallest wing is designed to stall, and then the second wing helps it recover then flies. Moving on to the tail-heavy Super Canard and how it would look like once the paper clips are attached to it and makes it tail-heavy. Once the tail-heavy Super Canard is thrown, the first wing stalls immediately along with it being tail-heavy. It then crashes. This is because the weight of the tail is pulling down while it's already stalling, so it immediately crashes. Middle-heavy Super Canard and how it would look like. The middle-heavy Super Canard, once thrown, flies for a short distance. It then stalls, then touches down gently. This is due to the weight applied to the belly of the Super Canard, and it flies very normally, but it flies for a short distance. Next up is the nose-heavy Super Canard and how it would look like. The nose-heavy Super Canard, once thrown, flies for the longest distance among the three because it denies the stalling action to be produced by the first wings. Since it is nose-heavy, it pulls the nose down so that it does not stall. It does not go into a stall. Then it would just fly straight and level until it loses momentum. Next up is the flight testing of the tube. The tube, when thrown, is very different from the previously mentioned paper aircrafts. The tube is thrown like a football, and if you throw it perfectly, it flies straight. And the downside of this is it is very sensitive to the wind due to its design. Now let's move on to the tube if it is tail heavy and how it would look like. The tail-heavy tube, once thrown, spins and crashes down immediately because the center of gravity won't be balanced anymore. And as we know, the center of gravity of the tube is located directly in the middle, and if you add weight to the backside, it would then shift, then that would affect the flight dynamics of the tube. Next up would be the middle-heavy tube and how it would be looking like. The middle-heavy tube, once thrown, if thrown in perfectly, it would fly normally but with a shorter distance because of the weight applied to the belly of the aircraft. Moving on to the nose-heavy tube and how it would look like. The nose-heavy tube, once thrown, flies the longest when compared to it having no weight, to it being tail-heavy, and to it being middle-heavy because of the momentum created by its nose heaviness, and it spins when it goes into a low speed. Sky King flight test. The Sky King, when thrown, flown the longest among all designs because of its great stability and great flight dynamics. Unfortunately, in the video, the Sky King hit an obstacle, but as I was observing its flight path, I could say that it would surpass the flight path of the Phoenix. Now let us apply weight to the tail of the Sky King and see how it would look like. The tail-heavy Sky King, once thrown, pitches down and rolls forward, then crashes, because the flight dynamics is greatly affected by its tail heaviness. Let's now move on to the middle-heavy Sky King and how it looks like. The Sky King, when it is middle heavy, actually flies normally but at a shorter distance than how it normally flies, due to it of course being middle heavy. We have now reached the final type of aircraft we're going to test today, which is the nose heavy Sky King, and let's see how it looks like. The nose-heavy Sky King, when thrown, flies at a short distance, then pitches down because of its nose heaviness. So it's just very, very simple. Due to its nose heaviness, it pitches down and crashes. Just for clarification, I used 3 large paper clips instead of 5 paper clips because when you compare those 3 large paper clips to the 5 normal size paper clips, it would be equivalent, and if I did 5 large paper clips, it would increase the weight added to the aircrafts very, very largely, and I think that would not make some of the aircrafts fly, at least. Nonetheless, thank you for watching this video experiment, and I hope you have a pleasant day ahead of you.